Hi everyone. This is part two of the statistics and probability lectures, and this is the fourth lecture in Data 101, right? So I'll continue with stats, and I'll be covering some extra concepts today. The first one being the central limit theorem. What is the central limit theorem? Let's say we want to sample from a population which has a sufficiently large sample size. In that case, we can approximate the mean of the sample to be normally distributed. Right? We can assume it to be normally distributed. And this is only if we have a sufficiently large sample size. This is extremely important here. So only if we have a very large sample, then only we'll be able to assume the mean to be normally distributed. And in this case, the mean tends, so the mean of the sample tends to the mean of the population, right? And the variance tends to, so in this case, the variance also tends to variance of the population divided by the size of the sampling. Now, let's say this is the entire population distribution, and there are, let's say, there are a few observations between 40 to 60, and this is the frequency of these set of observations. And this is basically the population distribution, and this is the sample mean distribution. So the distribution of the sample around the mean. So let's say um, there's the mean is, let's say, somewhere here, and this is the distribution around that mean, right? Um, Now, if you notice that this is quite uniformly distributed, and this is a random distribution. So this is here we can, since this is a large distribution, we can probably assume that this is normally the mean of the sample will be normally distributed, and this is basically the distribution of the mean of the sample, right? What about sampling? Now I've used sampling multiple times, and it is used to select, manipulate, and analyze a representative subset. So it is basically a subset of the entire population, right? That is a sample. And how we do that, how we select, how we manipulate and analyze the representative subset of data points, that is, the sampling. How we select that data set, how we select a subset of the data set. And this is to identify patterns and trends in the larger data set being examined. So that is sampling. And there are a few types of sampling. First one being probability sampling. Second one is non-probability sampling. Within probability sampling, I leave this to you to understand. You need to go through each of these types of probability sampling: random, stratified, systematic, and cluster. And here are a few images to support your understanding. Similarly, for non-probability, we have convenience, quota, purposive, and snowball sampling. So these are two types of sampling, and within each type, we have four types of sampling. Okay. When we talk about other concepts that you need to understand, so we've already covered mean, median, mode. We know what is standard deviation and variance. Uh, Apart from the central limit theorem, we also have the one-tailed test and the two-tailed test, which you can go through. These are simple concepts. And then we have types of data distribution. So that is here. What are the types of data distribution? Now, data can be distributed normally, right? That we studied. That is one way to distribute data, and that is most helpful for us when we solve data science problems. Right? This is normal distribution. Similarly, we have uniform distribution, right? And we have Bernoulli distribution. Within Bernoulli, we have, binomial geometric. Then we have Poisson, exponential. We have Weibull. Then normal is the most useful one. Normal or Gaussian distribution, this is also called. Then we have T distribution. We have log normal, and we have chi-squared distribution. Then we have gamma and beta. So we have various types of distribution. And if you've done a statistics and probability course, you will probably study the formulas corresponding to some of these distributions. For example, the expectation and the mean, right? The expectation or the mean would be different in case of a binomial as compared to a Poisson or an exponential distribution. All right. Then we have the probability concepts, right? I'll not be covering probability in this course. I think most of this you either already studied during your 11th or 12th or even 10th. or these are simple topics which you can study now as well. If you've covered a course in college, then I'm very sure that you would already know these concepts: covariance, correlation, Bayes theorem, and random variables. All right. Uh, Now, some types of charts. Data visualization is an important aspect within data analytics, right? And these charts can be made in Python, Excel, R, Power BI, Tableau, right? All these are visualization tools, even MATLAB. So all of these are data visualization tools that are very widely used. What are the types of charts that are there that are commonly used? First one is histogram. Now this is basically, when you have the frequencies of something, and you know that this is occurring for this much, this particular thing is occurring this many times, right? Or for example, in this case, we have the age groups and we have the per capita income. So for example, the 45 to 54 age group has approximately 55,000 per capita income in US dollars. Similarly, for various age groups, so we have per capita income for 5 age groups, right? So this sort of usually tells you the distribution of something when there are more than one categories, right? And for each category, it tells you what's the average number, the total number for that distribution. In this case, for example, 55,000 is the per capita income for 45 to 54 age group. Then we have box plot. Now this is again very important. Here we have, we can easily identify outliers. Now what do I mean by outliers? Let's say I have a point here and I have a point here, right? So first what I'll do is I'll make this box plot. This means that most of my data is distributed here. It lies here. This is the median, right? And when we define quartiles, so there's a particular definition for quartiles. There's a formula. So let's say this part is one quartile. This is the first quartile. Median is also known as second quartile. Then we have the third quartile. So this is the distribution of data, and we use those formulas to define what is the meaning of a quartile, and we distribute this data here. Now most of this data lies here, but there is a possibility that one point lies here and one point lies here. These are outliers, right? And this is helpful in identifying outliers. And anyway, box plot is very widely used in the industry in data analytics, and it is it is a graph which tells you a lot of gives you a lot of information, right? Then we have other charts. We have column chart, stacked column chart, percent stacked column chart, and similarly the bar charts, the horizontal version of these above three charts, stacked bar, percentage stacked bar. Then we have a spiral chart or a stacked spiral chart or a percent stacked spiral chart. Then we have funnel charts, right? Bubble charts where you can, these are helpful for identifying the increase in population or distribution of population, something on that lines, something on those lines. And then scatter chart is the very common one that we use. Then we have area chart, stacked area chart, and percent stacked area chart. Similarly, we have variations for polar chart. Pie chart and a donut chart are quite similar. And then smooth line chart. We even have pyramid chart, right? And then, when we are to track timelines for something, let's say I'm working in a consulting firm, I'll come across a Gantt chart very frequently. Why? Because it is used to track timelines. It is used to identify that, okay, till let's say 3rd of July, we'll be working on this project, on this part of the project. We'll take up the next feature. Let's say, since we are talking about, let's say, consulting, it might be we'll take up the second project from so and so date. And while working on that, we'll parallelly start, when we are halfway through it, we'll parallelly start with delivering the deliverables to the client. So that kind of a thing Gantt chart can help with, and it can even, within product management, it can help you build features as well. So it is for tracking the timelines and so on. Then within finance, we have candlestick chart and high low open close chart. So this can help you track stock prices, right? Or yeah, stock prices basically. So candlestick chart, you all must have seen. This is very common in trading apps, right? Even the crypto trading apps also have this candlestick chart. So these are a few types of charts, and I I'll probably touch upon data visualization again. But these are few very common types of charts which you should be very familiar with. Not all of this will be used, of course. The column, bar charts, scatter charts, bubble charts, these are more commonly used. But yeah, it is good to know all of these. Right. So I want you all to study probability basics yourself. This is not, first of all, this is not asked in interviews. It is asked very rarely in interviews. Second, you might have made notes of probability and statistics course in your second year if you've studied this course, if you've studied the statistics course. Even I believe commerce students might have a statistics course. Then we have this. So I've shared a pre-read. You can read this. This is stats for data scientists. I'll probably put a link in the description, right? And then once you've read this pre-read, you can also start exploring stats further through some online courses, right? Which can be on Udemy, Coursera, or even you can learn stats through YouTube as well. And of course, there are very good blogs on towards data science that can help you understand statistical concepts in detail. Next, we'll cover Excel, and it will be great if you watch Edureka videos on YouTube before coming to the session. And if you're not if you don't do that, it will be perfectly fine. We'll start Excel from scratch, and we'll basically cover the very first of all, we'll cover some basic concepts, like for example, we'll cover cell referencing, navigating, templates, the loops, right? And charts, filters, and then we'll move to the advanced concepts like VLOOKUP, HLOOKUP, transpose, right? Match index, pivot tables, which is extremely important, right? So we'll do all of this in the next session. So we'll move to Excel next. All right. Thank you, everyone. We'll meet again in the next session where we'll cover Excel. Thank you.